participants here today for the webinar, Comstech Distinguished Scholar Webinar by Professor Dr. Zahid Aleem, which will be focusing on the intersection of AI, human computing, and affective computing, its applications, challenges, and future directions. To briefly welcome and introduce the speaker for today, I would like to request Coordinator General Comstech, His Excellency Professor Dr. Mohammad Iqbal Chaudhry. Over to you, sir.
Thank you very much. Honorable Speaker of today, Professor Dr. Zahid Aleem, and participants from 10 countries. We already have 58, 59 participants already joined this very important webinar, which is one of the flagship programs of Comstech, along with many others. And this particular webinar series is actually based on the excellence of speakers, and that we invite the brightest and the best people in their own fields. And today is no exception that we have a very distinguished speaker today, Professor Dr. Zahid Aleem, from one of the most prestigious institutions, not only in Pakistan, but also in the region, which is called Ghulam Isa Khan Institute in Pakistan. Professor Zahid Aleem has expertise in many emerging areas of artificial intelligence, and this webinar will cover the convergence of AI, human computing, affective computing that holds immense potential for transforming various domains, including healthcare, education, and other fields. Professor Zahid will discuss the issues researchers are facing and challenges surrounding these fields, and of course, many other aspects, both technical and ethical. Professor Zahid Aleem is currently a full professor at the Faculty of Computer Science and Engineering at Ghulam Isa Khan Institute of Engineering, Science and Technology in Pakistan. He completed his PhD degree from the National University of Computer and Emerging Sciences, Islamabad, which is a premier university of Pakistan, in the field of computing. Until the year 2012, he was the youngest indigenously produced PhD in computer science by the country. He has received training in human subject protection from the Virginia Technical University, and prior to joining his institution today, he was affiliated with the National University of Computer and Emerging Sciences. So he has been into different high-quality institutions, both in terms of his own training as well as research which he has conducted in different countries. Professor Zahid is leading the Machine Intelligence Research Group at DGIK, where numerous graduate students and undergraduate groups are working in the domain of data science, machine learning, and data mining. He also works in the field of intelligent transportation system and effective computing. Furthermore, he has over 74 research articles, which I'm sure that are increasing with good pace, and that he has published many of these publications. In fact, all of them in high impact factor journal. Professor Zahid is also registered with the PACs. He's a certified trainer, Pakistan Engineering Council. He is currently invited as a resource person at HEC Quality Assurance Agency and top national universities. He's also a member of Higher Education Commission's Curriculum Review Committee, serving as the program evaluator for many of these prestigious national accreditation and qualification agencies. He's a recipient of prestigious Research Productivity Award from the Pakistan Council of Science and Technology. He has also received 6th and 7th HEC Outstanding Research Award in the Best Research Paper category. So certainly he has been not only productive, but also a very high quality researcher. For his academic performance in year 2016 has received the HEC Best University Teacher Award. And I'm sure that I can add on a lot more, but I'm confident that you are eagerly looking forward to learn from him and certainly to eventually interact with Professor Dr. Zahid Halim. So Professor Zahid, over to you.
Thank you, sir, for the nice introduction. Let me start sharing the screen so that the participants can see this material which I have. I hope I'm audible to everybody.
Yes.
So the topic which I'll be covering today is primarily the intersection of three different things, which include artificial intelligence, human computing, and the affective computing. Now, maybe probably you already have heard about AI, but there are at times it is treated as a misnomer as well. So I'll be throwing some light on that as well. And affective computing is a very different sort of thing. Generally, people don't have an idea of that. So I'll be explaining that, and followed by some applications and challenges. Some of the projects which we have developed here, rather they are in shape of products, and I'll be sharing my experiences about that. So okay, the timeline which I have been given is around 60 minutes. So I'll try to wind up in that, but the moderator can feel free to stop me whenever they feel convenient. So this is the agenda which I'll be following. So the primary thing is the background information about what artificial intelligence is. Now, AI is the ability of machines to perform tasks that are typically associated with human intelligence, right? And such as among these tasks, the important aspect of these tasks is the capability of the AI system to learn and also solve the problem, right? So primarily, the AI systems get their knowledge from the human beings themselves, right? Of course, if you are trying to solve some problem where proteins interact with each other, and you want to identify the group of proteins or maybe some clusters in that data. So of course, you cannot talk to a computer scientist regarding the expert knowledge of that domain. You will be requiring the expert from probably bioinformatics or some allied disciplines to let you know the training sample which you will be giving to the AI system, right? So, and similarly, if you are trying to develop a system to automate the judicial system, I mean, or the of a country, so that the honorable judiciary they are analyzing a case, they get data from one of the lawyer, and they get data from another lawyer, and then they put that data into the system, and they analyze them quickly that, okay, which law is applicable in this particular case. So in that particular case, the human knowledge cannot come from any ordinary human. That must be included into the system from someone who is expert in the constitution, and who is expert in the legal legislation system, right? So the AI systems primarily learn from a human intelligence, of course, the relevant and the pertinent one. But the two aspects which are important include the AI system to have learning and problem solving capabilities. So, okay. Now let me change it. Right. So some of the systems which we have available, commercially available system, which are actually the AI-based system, include advanced web search engines, which includes Microsoft's Bing, Google's Brad. So they basically have two things common in them, that they learn and they solve the problem as the problem appears there, right? Similarly, we do have health recommender systems, or even the simple recommender system. For example, if you are doing some online shopping and you purchased, let's say you purchased some soaps for your household use, and the recommender system will automatically analyze, okay, this guy is from this particular financial background, living in this particular geographical area, so maybe he's interested in purchasing this particular toothpaste, or maybe he may have this particular problem at his home. Maybe it will be suitable to suggest him this particular type of sugar to be utilized in the tea or other stuff, right? So these are the recommender systems. They are also AI based, and they learn through the data which they receive, and right, and also they learn while they are being used, right? Similarly, there are other systems that can assist you in understanding this speech. Rather, they actually don't assist you in understanding speech. They rather make the computer understand the human speech, because there are different dialects, there are different accents, there are multiple languages across the world. Generally, English is the most common international language which is spoken. So all of many of these systems, for example, Google Cloud Speech API, Watson's, this is IBM systems, Watson's speech to text, and Dragon for Mac. These are three popular softwares. So they are also AI based, where they learn from the data which they receive from the user, right? So, and same goes for self-driving cars as well. Waymo was previously actually founded by Google, but it is now separate company. Similarly, General Motors also has its own autonomous vehicle, self-driving vehicle. So it's not a static vehicle. It actually learns from the data which is received and automatically adapts itself to the environment. There are some other examples. Okay, let me cover this as well. For example, generative tools. These days, ChatGPT is very popular. So ChatGPT also it generates text for you, right? So based upon whatever it has learned, it generates a text for you, and the new generated text also gets fed back into the system, and the ChatGPT learns from the new data which it has received. Similarly, there are other tools. It's not a generative AI is not just limited to the text. For example, Deep Dream and Dreams. These are two different softwares. What they do, they generate images for you, and they generate videos for you for a given scenario. So this is all generative AI where they're used. For example, this GPT stands for generative pre-trained transformers. The transformers are primarily classifiers in machine learning, which are utilized for learning purposes. Now, whatever I have presented here, these were the examples of pure AI. However, we also need to know what is not AI, which is actually being publicized as being AI. So this include typical database systems, static algorithms, which do not learn from the data which they receive. For example, let me give you an example. There's a couple of mobile brands. And at times they sell their brand by mentioning that it has an AI camera, right? So actually what we need to know is that for a system to be classified as an AI system, we must need to know that if the system has the learning capacity, and also the system should have the problem solving capacity, right? So if, for example, if a mobile brand is publicizing its product as being an AI camera, and it sees that, okay, it can identify hand gesture. So what if I would like to make it learn some new gesture? Maybe I just clap and can it learn that particular event? Or maybe I blink my eye and the camera learns that event as well. If it does, okay, we agree that it is an AI system, but if it does not, so rest assured, it's not an artificial intelligence system. It is a static algorithm which is behind the working of that camera or mobile, whatsoever, which has been trained once, and it cannot learn as the new samples appear. Right? So that was somehow the crux of what AI can do. Now, let me now come to the topic where we have affective computing involved. So before that, we need to know that what is an intelligent computing. It is primarily, again, the artificial intelligence and the ability of computers to learn a specific task from data and experimental observation. Now, before covering the contents, the task of affective computing, probably I'm going to cover that in a while as well, but just for the sake of completeness. See, we interact with computers using our, probably if you're sitting listening to me, you're interacting with your machine. It can be a computer, a personal computer, maybe it's a laptop in front of you, or maybe it's a mobile phone. Again, all these three and other types, they are all primarily computers. You are interacting with them primarily using three things at present. Either you are using a keyboard, like I do have a keyboard in my lap, or you are using a mouse. I do have a wireless mouse placed on my table, or maybe you are using a microphone or a camera like me. Probably you're not, you're just listening. But in case it is required, your microphone and your camera will be turned on, right? So now all of these things which we press from the keyboard or the mouse gets input to the system, right? So this is how you interact with the computers. But there is an important aspect which we also need to feed into the computer, which we generally miss. That comes under the domain of affective computing. And what is that? That is, you need to make computer understand about your emotions. What is your present mental state? What is your present emotional state? Right? So that also goes into the system, maybe via your images captured through the camera, or maybe via the rhythm of key press events, which you press the keys or the click of the mouse right or left, and although they get entered into the system indirectly, but the computer cannot understand, cannot process that. So the domain of computing which deals with making computers understand or identify human emotion is this domain is known as affective computing, right? And the computers can be your mobile phone, your personal computer, desktop machine, or your other handheld devices, or maybe your laptop. So the primary objective here is that, and also you do have also you do have your computers in modern vehicles as well. Modern vehicles are computing so many things. So we do also have computers there as well. So the case study, the first case study which I am going to present here is that annually it is a relatively newer report where it states that annually 20 million deaths annually occur, and around these deaths, the ninth leading cause of these deaths is due to road accidents, right? And for probably some bus getting crashed into another vehicle, or maybe some bicycle getting crashed into a motorbike, so on and so forth. But why does all this happen, right? There can be many mechanical reasons to that. Maybe somebody is driving a vehicle and the tire gets burst, but the primary reason behind that is the human being who is driving the vehicle. For example, to give you an example, this particular gentleman is as you can read from his face, he's very angry, or maybe he's getting late from somewhere, and he's not in a stable emotional state while he's driving the vehicle. So not only is this person danger to himself, but more importantly, he's a danger to other, because he's not driving his vehicle in a stable emotional state, right? Similarly, if you see this, and this is another image for the sake of example, of course. This lady, she's driving, and as you can see, as appears from her face, she is probably very sad, but she is not focused on the vehicle driving, right? So, and this is again another example where a couple of people are driving the vehicle, and probably they're fighting because maybe the lady did not offer the guy breakfast in the morning. So they are probably upset about that, and they're fighting with each other, and at the same time they're driving as well. So all these reasons cumulates to road accident being the 9th leading a death cause to all the deaths which happened so far in the past decade. Now, how can we make computer understand, and how can we get this data from modern vehicles, and then we can identify about the particular human emotion of the particular driver who is driving the vehicle. Now the case study which I'm presenting here is that although you can do collect the data regarding a human emotion via multiple samples, for example, you can get the images of a person, and you can then identify if he or she is sad or not. But in the vehicle, the issue is that if a person is driving at night time, right, so you cannot get a clear, rather you cannot get a good image of the driver, because otherwise you will have to turn the light on, and that light should be placed on the driver's face. That will be added on as an extra distraction to the driver. So what we do is here is that electroencephalogram signals, we do have commercially available EEG caps. What they do is that they have multiple nodes placed on them, which a person can wear, and each node can give you various frequency band. For example, delta, theta, alpha, beta, and gamma. All of them have different frequency ranges. And what one can do is that one can ask, or we can have these EEG caps built into the modern vehicles, and the data of the driver while he or she is driving can be collected, right? So in our laboratory experiment, what we have done, we have collected this data, and for that we needed to design an experimental environment. So the experimental environment, I'm skipping this literature review stuff, where we identified that the music brightness while the driving, daytime or climate or traffic congestion mode, free roaming mode, or use of cell phone, and experimental's attitude, the person who was conducting this experiment, we classified these into 2 different sessions, where in the first session what we did is that the music was kept light, the brightness was kept high, it was daytime, the climate was sunny, traffic was low, right, everything was positive. And in the second experiment, with the same set of drivers, we had the music put to loud, brightness was low, the light was actually in the experiment, the driving environment was nighttime, it was rainy, and the experimenter who was collecting the EEG data from the drivers was a bit negative or harsh, and also the phone which we had placed in the vehicle kept ringing constantly, just to make sure that the driver gets distracted. So what we did is that from the first experiment, we took a sample of the EEG data, the brain signals, and also from the second experiment, we took the data. So what we did is that we inducted multiple drivers, and we had their EEG samples for a very positive environment and also a very non-conducive environment for driving. Now, after that, and for this, actually, we used a GT Force driving simulator. Later, we do have pictures of that as well. It's a product by Logitech. So we collected that, and it was a complete driving environment. Then once the drivers drove the vehicle, after that, we also asked the driver to express their emotions using self-assessment mannequins, right? So there is a there's a model that is called PAD, where you can identify yourself. For example, it has one dimension. This is called pleasure. The second dimension is called the dominance. The second dimension is called the arousal, PA. This is pleasure, this is arousal, and third one is called dominance, right? So for example, if I'm here, I'm talking about artificial intelligence and affective computing. So if I have the domain knowledge, so of course in this dominance, I'm going to click this most dominant one, right? And maybe if you ask me to talk about, let's say, biochemistry, and I don't have any knowledge of that, so in dominance, I'll be of course clicking this smaller one, because I'm not dominating on that particular topic. You can do this for sports and as well. And similarly, if you're listening to, right? And if you are, for example, I'm talking about AI and you are listening here to listen about AI, so you will be a bit aroused about that, okay, I'm excited to listen about AI. But if you have no interest in AI, and probably you have interest in painting or maybe some drawing stuff, and so in that particular case, your arousal state will be minimum, and in case if you're interested to listen about AI, your arousal state will be maximum. And of course, if you after this particular seminar, if since it's an online seminar, but just in case if it was a physical mode, and after that you got chocolates to eat or maybe some pastries to eat, so probably you would have been pleased, otherwise maybe you would not have been pleased. So this is a paired model. Now what we do, once we have collected the data from the drivers, multiple drivers, it was I think 69 or so, right? So after that, what we did is that we took their own self-assessment as well, what they did. Now what we after that we assigned labels to that particular data. For example, for a particular set of driver, for example, this is driver 1, this is driver 2, this is driver 3, and similarly for the same driver, we got his or her data, in the environment environment 1, and then in the second environment we also took his data, right? And these were EEG signals. Now what we need to do is, here we need to assign a class label. For example, if the person is stressed or if the person is not stressed. Now this set of data gives, and again, I've just written 3 samples here. When you collect data, EEG data, it contains thousands of samples being collected per second, right? So it's a large data set, right? So what we did is that we collected that data, and it was and the features from these data were extracted. These features were both time domain features and also the frequency domain features. Once we did that, after that we can identify which features are important using the principal component analysis. These are multiple techniques. For example, let me give you an example. I don't know if you're currently looking at the PPT or my video. Maybe if you're looking at my video. So if you see this hand of mine, if I ask you what are the prominent features in this hand, so of course these fingers are the prominent features, right? So same goes for the data as well. So these feature selection techniques let you identify the prominent features which are there in the data, and then those features are fed into the classifiers, and then classifiers identifies that if okay, the person is stressed or he is not stressed, right? So this is the training part of the AI, and once we have done that, but before that we need to clip certain things from the collected data. For example, there are some very low frequency items which gets recorded into EEG signal. To give you an example, see, I'm talking to you at present. So whatever I'm doing at present is getting reflected in the signals which are generated through my brain, right? But at the same time, to give you an example, at the same time, if my cell phone starts ringing, right? Or maybe I am feeling cold, right? So that signal also goes, cell phone starts ringing, I get distracted, that thing also gets recorded into the EEG signal. Maybe there's low temperature here and I start feeling cold, that thing also gets recorded into the EEG signal. But primarily, if I'm recording the data against some driving environment, so I'm interested in that. So this otherwise data which gets recorded needs to be clipped out from the actual data. Fortunately, that can be done using low pass and high pass filters, where very low frequency and very high frequency can be clipped. So we do that as well. And these are the examples of the feature extraction and time domain features which we extract from the recorded data. And then and this is standard method where you on the EEG cap, let me draw it here. So this is an EEG cap. See, this is the nose of a person. For example, this is ear 1 and this is ear 1, ear 2. And here in the EEG cap, we have one node here, 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 another node here, so on and so forth, right? So what happens is that this is the classification where we have 14 electrodes, right? So maybe this and maybe this one here and maybe this one here, right? So these 14, combination of these 14 electrodes give us a PSD14 sample, right? So this is called the power spectrum of these 14 electrodes. Similarly, DASM is also a combination of different nodes here. And rest of the stuff is like that as well. So this is combination of various electrodes and the data which we get from these electrodes. They can also be used to extract the frequency domain features from the data. So what we do is that from these samples, we extract theta, alpha, high alpha, low beta, gamma, and all features for the EEG signal. And once we have done that, then we simply use the artificial intelligence classifiers, we call machine learning classifiers as well, to predict a person state. So what we achieve is that we have an accuracy of 97%, where in the 97% cases, we can correctly identify if a person who is driving a vehicle, is he stressed or if the person is not stressed, right? So this is how we can communicate about the emotional state of the end user to the computer, or in this particular case, that is the vehicle. And of course, the vehicle can then trigger a corrective action. Maybe it can report it to some emergency services, or maybe it can alarm the driver itself that you are not focused towards your driving. That can be harmful and ultimately can cause a car crash. So you need to focus on your driving and forget about the other stuff which is going throughout your brain, right? So the second example of affective computing, where machines can identify human emotion, is from a sort of human-centric study. For example, just imagine this webinar. We are different people from across different countries. Since it's an online webinar, maybe you're not physically, of course, you're not physically there, but just imagine if you were physically in a big hall, right? And you were from Nigeria, somebody from Pakistan, somebody from Turkey, somebody from, let's say, some other country. And for the first time you entered there, right? And all of it. So you need to talk to somebody, break the ice, introduce yourself, get acquainted with the other people. So which of these guys will you be talking to? Let me imagine myself. Probably I'm going to go talk to this guy, right? And maybe in your case, maybe somebody would like to talk to this guy, or maybe somebody would like to talk to this particular person. But it all depends upon your own personality which you have. So you tend to talk to people of personality which is closer to your personality. Now, what is the human personality? There are multiple models of human personality. But this big five model is generally the largely used model in the literature and in public systems, where it says that every human being has 5 aspects. And it is called ocean. O-C-E-A and it is called ocean, and O for openness, and the rest of the things for the others. I'm explaining to you these shortly. So openness, basically, in a human being, if somebody is very high in openness, so that person will be more creative, more curious about new things, and open to new idea and novelty. But maybe you meet somebody who is very low in openness, right? Maybe just imagine about your boss, or maybe the boss can imagine about his boss, or maybe a student can imagine about their teachers, or maybe the teacher can imagine about their students. So you can have people with high openness, low openness. So high openness people will be creative, curious, open to new ideas. But people with low openness, if somebody gives them a new idea, okay, you for example, just a wild thought that, okay, you are always wearing a dress shirt and a tie, you should start trying t-shirts, right? So this is an idea, wild idea. But if somebody is low in openness, he is not going to appreciate that and will not be encouraged. But if somebody is higher openness, he or she is going to try. And similarly, if there's another but so this openness personality aspect is available in each and every person. Somebody is high and somebody is low. Same goes for conscientiousness. If somebody is high in conscientiousness, the person will be organized. He will be managing or he or she will be managing his or her time appropriately, and will always be managing stuff. If somebody is low in conscientiousness, they will be doing their stuff randomly, won't be very accurate about time management and stuff. Similarly, the third aspect is extraversion. So if a person is extrovert, right, so they will be always open and they will be expressing their feelings publicly. As compared to somebody who is low in extraversion, of course, we have a word for that, that is called introvert. So what such people tend to do is that they keep their emotions or their feelings to themselves and they do not express them publicly, right? And the another aspect, the fourth aspect, is the agreeableness. For example, if you ask somebody, okay, we can have dinner outside tonight. So if he or she agrees, and then you give no more ideas, and they always agree, they say they're high in agreeableness. And somebody low in agreeableness is always going to disagree to whatever you present. But again, in various corporate structure, we need people. For example, if you are working, hiring people for military services or police services, you need to have people who have high agreeableness, right? But if you are demanding people for some creative work, so maybe you will require people with low agreeableness so that they can bring forward their own ideas. And the last one, fifth one, is neuroticism, where a person who is high in neuroticism is more fearful. He is or she is more tensed and stuff. Whereas those who are low in neuroticism are more confident and stuff. Now, what we need to do is that there are available methodologies where somebody can identifies somebody's personality. For example, there is a typical paper and pencil method where the psychiatrist asks you to maybe give you a scenario and ask you to write a picture, or maybe for a given picture they ask you to write a story, and based upon that story you can the psychiatrist can identify your personality. Or maybe, for example, if you go on a date and the person you are dating, they intentionally ask you to, can you please bring me a glass of water, and while you are going there picking up stuff, and they are judging your personality, right? Similarly, for example, this is a picture, and I ask you to write a story on that, and based upon the contents which you have written, we can identify which personality category do you have, right? For example, let me give you an example. Now, all of you participants, you are listening to me. So if I ask you that from one side of these stairs, you have to go up, and from the other side, you have to come down. But the choice is yours. For example, you can go from left to right and from right to left. So this choice is yours. So if I ask you quickly, don't answer me. Instead, keep the answer to your mind. So probably you have by now chosen to go from up, from right, and down from the left, or maybe from left to right. So it's a study where we can, and it identifies that if your language, the script, the language we use generally for writing, for example, Arabic, if it's written from right to left, you are always going to choose the right stairs to go up and left stairs to come down. And if your language, for example, English or French, it's written from left to right, then you are going to use the left stairs to go up first and the right side stairs to come down. Similarly, now, for example, if I ask you to identify, these are coffee beans, and there's a person hidden here, right? If you can identify that. Meanwhile, let me have a sip of coffee. So if you are able to identify that person here, if you cannot, let me help you. So this is a person hidden here. So if somebody searches this person in 20 seconds, it means the left side of their brain is working faster as compared to right side of this brain. Now, why have I told you all these stories? There is an idea behind that. See, when for the recruitment purpose, after a person is evaluated technically, the recruiters at time would like to judge the personality of the prospective employee as well, right? But if you know your personality is being judged, you are going to fake it, right? So what we do is that we use artificial intelligence and computer games here. Right? So the idea here is to, first, what we do here is that we induct certain participants, and what we do is that we ask them to play computer games. These are not random games. These are real world strategy games. The three games, any one of these can be used, but for our experiments, we used all three of them. These include Age of Empires, World of Warcraft, and Starcraft. Now, once we have identified, we have asked the users to play this game, we also collected the personality score of these participants. There is a well-known test that is called IP test, right? So we also got that IP test as well, and then we used as a step 3, we recorded the game logs from the data, and also we clustered this data using the artificial intelligence techniques, which are k-means, k-medoids, and fuzzy c-means. These are clustering techniques. And then what we do is that once a person appears, so instead of asking, a new person appears, instead of asking the personality related questions or questionnaires, we ask him or her to play a game. And once he or she has played the game, we do have his or her personality scores, right? So let me show you some of the results, technical results which we have. For example, these are the features which we extracted from the games. We asked the users to play, and these are some of the feature selection results. And then these are the results of the k-means, clustering, and since we did a lot of multiple experiments on clustering, so all of them have been summarized here. Maybe it will be too time consuming explaining each and every result, but I'll be explaining shortly the crux of that. And the clustering is an unsupervised learning, so we need to identify that which of the clusters are the best clusters. So what we do is that we have cluster validated indices, DBI, DI, SC, and there are many others as well. So based upon that, we identify the best clustering formation, and then it gives us that primarily the data which we collected from the subjects, it had 2 clusters. Right. So here it is shown in shape of graph, but for your convenience, I drew a figure of that as well. where in the cluster 1 we have people who are who are cooperative, who are kind, and who are high in agreeableness. These people tend to go for modern technology in games. They tend to collect money a lot, and they tend to store their money in banks as well. So this was the property of cluster 1. Whereas in the second cluster, or in the second group, we had individuals who were more neurotic. They were more assertive, and they were more talkative as well, and they had a more of the anger emotion as well. These people in the computer game environment, they always remained in the old age. The various environments of the game had various ages, and they relied on obsolete or relatively old technology to fight, so on and so forth, right? So we were able to identify these using the artificial intelligence algorithm, right? So this is the figure. This is the image of the GT4 simulator, which we used for the driving environment, which I mentioned. So these are okay. Okay, let me explain this actually. So the future direction which we are presently working on is that generally in the Pakistani subcontinent culture, if you go for proposing somebody, okay, right? So wherever you go, their parents are going to judge you if you are a smoker or a non-smoker. And if you know you are being judged, or maybe if you get angry a lot or not, of course, they know about your bank balance and family, but they want to judge your personality, right? So if you know about the fact that you are being judged, you are going to show as if you are the best person in the whole world. But maybe not always, but maybe you are a very different person as compared to the person which you predicted, right? So the concept here is that what we can do is that using the driving simulator environment, this experiment we already have conducted, but we are in the process of extracting the key results from this. But using this, what we would like to do here is that using the actual driving features, we would like to identify the human personality, right? So this is one of the future undertaking which anybody can do. And now I'm moving towards the closing of this talk. So I do have a couple of different slides as well. For example, maybe many of you are academicians, or maybe some graduate or undergraduate students. This is one of my favorite stuff which I used to talk about in every talk which I give, irrespective of the content, is that doing MS or Masters or PhD is okay, it's fine. But if you have done your Masters and PhD, you do not do your research after that, this Masters or PhD is useless, right? But if you are doing research, right, and you are not publishing that research in high quality venues, of course, high quality journals with impact factor, or maybe co-ranked conferences, so this research is also not useful. But again, once even you are doing this as well, but if your research is not doing any of the two things which I'm going to mention here, so if any of these two things are not happening, then your research is also useless. And what are those two things? One, either you should be commercializing or maybe earning some money out of your research. Right? It's not always that whatever research you do is acquired by Motorola or Siemens or maybe Nokia or Philips. Maybe in the world of computing, you can simply develop new algorithms, get a domain name, and put it for public use. You can get a lot of revenue using Google ads or other ads as well. Right? So your research is useless if you're not either earning revenue from your research, or you are not serving the society through your research. Or it's not always about money, it's about giving back to the environment as well. So your research should, maybe your research is helping in having less pollution, or maybe water conservation or something like that. So this is quite important. So these are a couple of examples of what we have commercially developed here in our laboratory, where we have used depth camera to identify the sign language. And then we also, the experiment which I was mentioning, so we have developed this simulator on our own. Then we also have developed interactive games for limited physical space. And then in the brain-computer interfacing, we have developed algorithms which can identify human state and use that for controlling the user interface of the computing. With this, I come to the end of my talk. Just one mention. I think irrespective of whatsoever we talk about, we should be careful about the consumption of food we have. Generally, actually, I do have this slide in physical mode where we usually have some tea break after the session. So I'm just mentioning that make sure whatever food you consume, you use it with care. So food does not get wasted, because there are a lot of people around you, us, who are starving, and they're searching for food in garbage, and if you're wasting it in our plate, so it's unfair to them. This is a brief introduction of my university, Ghulam Ishaq Khan Institute of Engineering, Sciences and Technology. The university is just next to Tarbela Dam, which is probably the second world's earth-filled dam. So anybody, if you would like to visit us, we would be happy to host you. That's all from my side. Thank you for listening to me. And I hope the session was useful. I'm open to questions.
Thank you so much, Professor Zahid. What I will request the participants is, whoever has a question or you have asked before, just send it again in the chat so we can have it and we can ask Professor. There's one question from Aruj Arshad, sir. It says, what about the imposters? Can affective computing identify an imposter? How far this technology can identify an imposter? In other words, how far AI and affective computing system is foolproof?
Right. So that it's a very good question. One of my favorite questions. Actually, the task here is to identify Hodgson effect, where the Hodgson effect says that somebody can fake their signals or emotions or their personality, right? They fake it to bluff the human evaluator, right? So the effective computing can very fairly identify an imposter. So the results which we had, we could identify the wrong personality, or for that matter, imposter, with an accuracy of 97%. So it can identify that. So let me show you some of the results. So if you see here, the average of these results, we do have accuracy of different classes. For example, if you see here, we have a sensitivity of 0.98. It means in 98, generally it means that in 98% of the cases we have correctly identified. So so the answer to your question is that we can identify.
Sir, we have another question from Naveedur Rahman. In emotion-based detection, maybe deep fake can be involved about data set. What will you do about this?
Yes, of course. Now, this comes under the data collection methodology which we use. See, if I train my machine learning classifier with the data which is full of noise, which is full of inaccuracies, which is full of obsolete observations, right? So my machine learning classifier is not going to learn. So this is the task of the computer scientist or the AI expert who is developing those algorithms, to make sure to give all possible sort of samples to the machine learning classifiers. Now, the question here is that what if somebody has given an input image using deep fake technology, right? So if I don't know the background of the individual who has asked this question, but in our academic setting, we identify the originality of the users or of the students' thesis using software like Turnitin, and there are other softwares as well, right? But with the advent of ChatGPT and stuff, the students have started using that to write their thesis. But the Turnitin and other such softwares has now used artificial intelligence to track the content which is written by AI itself. So here AI is detecting AI itself, right? So that can be done. So if deep fake or other technologies, they are based on AI, but at the same time, AI can also be trained to identify AI. It's just a matter of giving those samples in training to the classifier, and once it gets trained on those samples, it will be very easy for the AI to identify that.
Okay, sir, we have a question from Dr. Qayyum Zafar, UMT Lahore. Could you please explain difference between text generative tools like ChatGPT and general search engines?
Right. So the generative tool, you see, they are based on pre-trained transformers, right? So what they do is that they generate text using the LLMs, right? So they do that one. Whereas the general search engines rely on page ranking algorithms. Although they are some sort of, you can call them AI, you can call them in inverted commas in AI, but they primarily rank various sources of information. For example, if you write something in a search engine, for example, the best pizza around me, right? So you write that in a search engine and you press enter. What it will do, it will scrap whole of the internet, whichsoever it can have access to based upon your shared location, which maybe you have shared using your mobile phone GPS. And what it will do, it will search for the keywords on different websites and reviews. It will search for the keywords like best, pizza, around me. For that, it will make sure that whatever your location is, and the website also provides their services on those locations as well. And based upon that, it will shortlist maybe 20 locations, and then it will rank those locations, right, and show you those results. So most of it in search algorithm is sort of statistical ranking algorithms, and they rank the results and they present the results to you. Whereas in generative AI, the new contents are generated from previously learned data.
We have another question from Aruj, I think, in continuation to the first. Are there ethical concerns associated with using effective computing for identifying imposters, such as privacy issues or the potential for bias?
Yes, there are ethical issues. It's a very good question, but there are ways to train your classifiers. For example, if you are giving your data to the computer, maybe in shape of an image, or maybe in shape of text, or maybe in shape of your email, whatever, you have given that as an input to the computer. Now, the classifier is going to learn. Now here, between your input and the classifier, there's a layer generally, but that honestly depends upon the AI expert who has written that algorithm. So the task is to camouflage your data. So it is not going to present your raw data to the machine learning classifier as it is. It is going to encode it in a third form, and that third form is going to be given to the machine learning classifier to learn. So machine learning classifier won't be able to identify the contents. For example, if you would not like your image to be learned by, but all of it depends upon the particular algorithms. So on the face of it, you cannot predict if the machine learning or AI classifier is following those rules. So yes, your question is right. There can be ethical issues while you are using AI. There can be, and honestly speaking, many times there are actually ethical issues. Most of these systems are not using those, and your data gets compromised. One, And the solution to this is standardization. We need to have standards in the AI community that whatsoever algorithms gets commercialized should be following those standards, where the privacy of the individual or the data should be protected. But at present, honestly speaking, in most of the cases, it is compromised.
We have another question, but I think you have already answered a chunk of that, is how can we control the unethical use of AI? So I think you have also mentioned. There is one more, which tool is allowed for students for writing the thesis? I don't know.
So somehow it's not within the domain of this webinar, but I would like to answer this as well. See, what is the purpose of asking a student to write? We need to first answer that. If your professor or your teacher is asking you to write a paragraph or 2 pages report, they are just training you to make sure that whatever is in your brain, you get that communicated in a proper manner. If you are a computer scientist, you may write a DFD, STD or something, or maybe an algorithm for that. If you are a physicist or you are a chemist, maybe you can write an equation and you can communicate that. Of course, around that, you can write a couple of paragraphs, right? So that is what is required. Now, let me answer this from the perspective of the student. What the student they want their report to be well reflected to the professor, right? So what I suggest is you should go for using tools like ChatGPT, but don't use them to generate your text. What you can do is write your text on your own, in your own writing, whatever language you write in and what vocabulary you have. But you can use these tools for proofreading. Right? You can ask them, okay, proofread this to identify some spelling mistake and stuff. So it will fix you, but your main thought will be yours. You can ask. But if you ask these tools to write me my master's thesis on finding protein-protein interaction to identify conflicting edges, for example. So this is academic dishonesty. So what I suggest is that you can use technology to assist you to achieve your goals, but you must not use technology to fake what knowledge you have.
Thank you so much, Professor. I believe these are all the questions. The rest are all thanking you for such an insightful presentation. They have truly enjoyed it. So I would like to thank you once again for taking out such precious time of yours and delivering this webinar. And also to thank the participants. We have had a good participation throughout. We have had around 100 people joining us from over 10 countries. So afterwards, we will also upload this webinar on the YouTube channel for anyone to revisit your lecture. So thank you so much, Professor. And we look forward to having more such webinars from your end.
It was a pleasure, and thank you all the audience for patiently listening to me. I can reach to via my email ID mentioned in the presentation. Thank you so much. Thank you so much. Bye-bye.
You can share the presentation with me and your contacts, and I'll share it with all the.
I will drop an email and you can share it with those. Thank you. Thank you. Bye-bye.
Thank you.